Assalamualaikum and hello. Okay, welcome to online video learning for transport processes. So my name is Nadia Adrus and this is Heat Exchanger topic part 1. Okay, let's go to the introduction part. So for the introduction part, I believe all of you have done the preliminary work by looking or by watching the video from the YouTube link that I have shared previously. So this is just like a recap or summary on what have you already seen. So first of all, I would like to explain or define what is heat exchanger. So heat exchanger is actually a device which is used to transfer the thermal energy. So the transfer of this thermal energy can occur either between two or more fluids, between this is like a liquid and liquid, for instance, and between solid surface and a fluid, and also between particulate solid and a fluid. Okay, so actually it is a device. Okay, heat exchanger is a device. So and for heat exchanger, there must be at least two minimum streams that involve. And what are those streams? Those streams are the first one is cooling stream. Cooling stream means the stream that enter at low temperature and leave the heat exchanger at high temperature. Meanwhile, heating is the stream where it enter at the high temperature, and as soon as it transfer the heat to the cooling stream, then it will leave the heat exchanger at low temperature. Okay, so you can also read more on the mechanism involved in heat exchanger. So you refer your textbook on section 4.9a, page 221. Okay, actually from there you can see that there must be at least, oh no, not there must be, the mechanism of heat transfer for the heat exchanger is actually two. Okay, so the first one is via convection, and the second one is via conduction. So via convection meaning that, for instance, if you have a shell and tube heat exchanger, the heat transfer from the fluid inside the tube to the tube wall. So this occur via convection. And meanwhile, the heat transfer through the tube walls is via conduction. And the next one is from the tube wall to the fluid in the shell, the heat transfer will be occurring via convection once again. Okay, so you can read from your textbook on my explanation just now. Okay, so of course, you want to know what is the task of heat exchanger and what are the purpose of heat exchanger. Okay, so basically, heat exchanger is not only for heating but also for cooling. Okay, meanwhile, heat exchanger is also used for boiling, and it also involved in the condensation process. Okay. So for instance, you can see a process flow diagram here. Why you need to heat your sample or your reactant before it is entering the reactor? It is because normally your reactant or your chemicals is at room temperature or at the ambient temperature. Meanwhile, the reaction takes place at even higher temperature. So in this case, both reactants need to be heated before it entering the reactor. This is because if it enter the reactor without heating, the reactor here will decrease in the temperature. So therefore, you need to have preheating so that your reactant comes into the reactor at the temperature of reaction. Okay, and after that, okay, after the reaction has taken place, okay, before you proceed to the next unit operation, what you need to do is you need to cool it down, okay, before you enter the flash distillation column, for instance, in this case. So therefore, you also need a heat exchanger in this case to decrease or to reduce the temperature. So that means heat exchanger, the task is not only for heating, but the task is also for cooling. Okay. So with that, we come to the purpose of heat exchanger. Okay, heat exchanger, there are at least 3 purposes in general. Okay, so it is used to control the temperature for the process. Okay, as shown here, if your reactor, you cannot control that at 250 degrees C, that means maybe your reaction will not proceed as good as it is, so it will affect your product quality, right? And the second one is you need the heat exchanger for the conservation of energy. Okay, so for instance, in this case, first of all, you heat, right? And then when you heat, actually you absorb the energy. Okay, meanwhile, for cooling, you release the heat. Okay, so you can use the heat exchanger in order to conserve this energy. Okay, the heat because after you do the reaction, okay, the heat which is released here can be put it back in the heating here so that you can conserve the energy. So this is also the purpose of heat exchanger. So you can do this actually in the HEN, so-called heat exchanger network. Okay, and last but not least, you need to have a heat exchanger for protection of environment. Okay, can you give one example how the protection of environment uh, is related, is very relevant on the use of heat exchanger? That means why heat exchanger is relevant in order to protect the environment. Okay, maybe you can think about one example. Okay, so next, I just want to show you some overview on the application of heat exchanger. I think previously you have also seen there are many application of heat exchanger. Okay, for instance, in car radiator. Okay, in order to prevent overheating of the engine. Okay, and for the household application, you have the heat exchanger in the form of air condition. Okay, and also in industry where you see that very bulky size of heat exchangers, and this heat exchangers is actually used for various needs. Okay, so maybe I don't go into further details on the application because you have, or you can also read on your own, and you can also recall or recap from the previous video, which the link I have shared. Okay, next, in the previous video, you have also come across on the efficiency of heat exchanger. So there are several factors that may affect the efficiency of the heat exchanger. So the first one is temperature difference. So temperature difference meaning that the difference between two fluids. Okay, and the next one is the types of conducting materials. So because different materials have different thermal conductivity, the higher the thermal conductivity means the higher rate of heat transfer. Then for heat exchanger, surface area is also very, very important. Okay, because the higher the surface area, meaning that the higher the heat transfer rate. Okay, and the third one is about fluid velocity. Of course, in this case, you need a pump. Okay, you are no longer depend on the natural convection, but mostly on the forced convection, where the velocity is the source of velocity is from the pump, for instance. Okay, actually, for velocity, you need also to control. You cannot have too slow or too fast. Okay, so can you please think one reason why the fluid velocity cannot be too slow? Okay, and please also think why the fluid velocity cannot be too fast. And the last but not least, the third one is the fluid turbulence. Okay, turbulence means you have a well mixed boundary condition. Okay, so when this is occurring, that means you will have the greater energy transfer. Okay, I hope that so far you understand on this slide on the introduction. So let us have a look on the next slide.